Part 3. Power for a three-phase balanced load. For the circuit shown, the apparent power, SZ, so we're looking at the complex power now, even though as shown as a resistor, it's marked as Z, so it's the apparent power, to each impedance has to be the line voltage over root 3, because that's the line voltages here. This is a phase voltage, so that load is seeing just a phase voltage, so it's EL over root 3 times the line current, because the line current and phase currents are the same. Yep. So the total apparent power, because this one is SEL over root 3 times IL, but we've got that 1, 2, 3 times in this system. So the total apparent power must be 3 times that. And if you do 3 over root 3 in your calculator, you get root 3 as a result. Okay, so the total apparent power, ST, is root 3 times the line voltage times the line current. Okay. Furthermore, since phase voltage is given by EL over root 3, so the EL over root 3 bit in this formula here, we can substitute in E phase. So substitute that into there, we get ST is equal to 3 times the phase voltage times the line current. So there are a number of ways there, depending on what you might have been given in a problem, to get to the total apparent power for that system. Yep. On to the next page, three-phase balance load for delta. Okay, it's the currents that are different in delta. It's the line voltage that's fixed, the same for both phase and line. So we get, for each of the impedances Z, we get a maximum total apparent power for each impedance of IL over root 3. IL over root 3 gives me the phase current, and multiply that by the line voltage. Again, we've got 1, 2, 3 of those impedances, so the total must be 3 times that value, and again 3 over root 3 is equal to root 3. Therefore, total apparent power is 3 root 3 times EL times IL. You'll notice that that is the same as on that page, but it does not mean that if those impedances are the same value, 10 ohms or 100 ohms, in both systems, it does not mean that the total apparent power in the star system is exactly the same as that in the delta system, because the currents will be different. Okay, so I wanted to point that out. The fact that those two equations on those two pages are exactly the same does not mean that the total apparent power in these two systems, a star connected system and a delta connected system, is the same. And we will prove that in an example later. So furthermore, since a phase current is given by root 3, IL over root 3, we can substitute IP into there for IL over root 3 and end up with total apparent power in a delta connected system is 3 times the line voltage times the phase current. So in a star connected system, it's 3 times the phase voltage times the line current, and in the delta connected system it's 3 times the line voltage times the phase current. Yeah. So again, there's a number of ways there to get to the total apparent power for a given system, depending on what you've been given in the first place. Okay, and again, got a nice little summary slide that puts all that in one place. For star connected system, total apparent power is either root 3 times EL times IL, or 3 times EP times IL. And for the delta connected system, we've got root 3 times EL times IL. These two again being the same does not mean that they get the same power if we change the connection of a delta as what we had in star. And we can also use 3 times the line voltage times the phase current. Okay, everyone happy with that? Clear as mud, eh? We got on the next page. Right, I'll